Hi guys, and welcome back to another episode of Brad's Whiteboard Chronicles. Today we're going to be looking specifically at quadratic equations and focusing on factorising. So what is a quadratic equation? So the general quadratic equation looks like y equals ax squared plus bx plus c, where a, b and c are your coefficients. You can see we've got three terms. And we can also notice that the highest power of a quadratic equation is 2. Right? So we've got a squared. So ax squared, right? The highest power is 2. So we're going to be focusing on looking at factorising today. And there's a few different rules that we can use to factorise a quadratic equation. So jumping into example number 1, we've got the equation x squared minus 5x equals 0. And also have written here common factor. So we're going to factorise this equation by using the common factor rule. So you're probably wondering, well, what's a common factor rule? Well, the common factor rule says that what we try to do is we try and pull out a common factor between the two terms and try and just make the equation look simpler. So in this case here, we have x squared minus 5x equals 0. So what's common about these two terms here? Well, we can see that both terms have got an x, so it's a common term. So we're going to pull out our x. And we're going to have x minus 5 equals 0. Now the next thing we're going to look at is solving for the equation. So generally when we solve for x intercepts, we've got to make y equals 0. So in this case here we have y equals ax squared plus bx plus c. So how do we solve for x intercepts? We make y equals 0 and we solve for x. So in this case we already have y equals 0 and we're going to be solving for x. So now we can rewrite this as x equals 0. So with x equals 0 and x minus 5 equals 0. So we've pretty much split it up, right? So then we can solve for x. Now here we know x is 0. So x equals 0 and y equals 0. That's one of our intercepts. And our second intercept, so we can bring this 5 to the other side. So I've got to add 5 here to cancel it and add 5 here. X equals 5. So we can say our second intercept is 5, 0. Right? So what we've done here, we've looked at our quadratic equation, we've factorised our quadratic equation, and we've found our x intercepts for this quadratic equation. So now moving on to number 2. Now we're looking at x squared minus 4 equals 0. So you'll notice that we've got a squared term, x squared term, and just a term without any x's in it. So if we look at our original equation, we've got y equals ax squared plus bx plus c. So here we're missing a term with a bx. We don't have a bx term in this case. Right? So in this case here, to solve a problem like this, you'd be looking at perhaps the difference of two squares, which is another rule that we can use for factorising. And that pretty much says that you're going to be saying x minus the square root of c is going to be within one bracket, and then within the second bracket you're going to have x plus the square root of c equals 0. So if we were to apply that, we would say x minus square root 4, and then we'd have x plus square root 4. So what do we know the square root of 4 is? It's 2. So x minus 2, x plus 2 equals 0. Right? So again as before, now we can solve for our x-intercepts. So we can say x minus 2 equals 0. Bring the 2 to the other side, so x equals 2. And we can say x plus 2 equals 0. Bring the 2 to the other side, and x equals minus 2. So our 2 points are 2, 0, and minus 2, 0. There are our two x-intercepts. Right, and just for the sake of checking that this is correct, we'll expand this out and get back to our original equation. So if I was to expand that out, if I was to say x squared plus 2x minus 2x minus 4, x squared, this cancels out with that, minus 4. So yeah, x squared minus 4, x squared minus 4. So we can say that yes, this has been factorized correctly. And these are our x-intercepts, 2, 0 and minus 2, 0. Okay, so now we're going to look at our third equation, x squared minus 5x plus 6 equals 0. So this says use the common factor rule. The common factor rule says we're looking for two numbers which add up to minus 5 and multiply to 6. So they've got to add up to b, so two numbers that add to b and multiply to c. So here in this case c is 6 and b is 5. So we've got to find two numbers that when multiplied together equals 6, but when added together equal minus 5. So in that case these two numbers would be, these two numbers would be minus 3 and minus 2, right? So if we add minus 3 and minus 2 together, we get minus 5. If we multiply minus 3 and minus 2 together, we get 6. So we can factorize that, and we can say that, okay, we're going to have x minus 3 and x minus 2, right, equals 0. So if we were to factorize this using the common factor rule, our two common factors are minus 3 and minus 2, which gives us this. Now we can solve and say that x minus 3 equals 0. Again, we're going to bring the 3 to the other side to get x equals 3. And x minus 2 equals 0. We're going to bring the minus 2 to the other side. So these are our intercepts. Right, and just as we've done here, just to prove that once we expand that out, we're going to get that, I'll expand it and say x times x equals x squared, x times minus 2 equals minus 2x, minus 3 times x, minus 3x, and then minus 3 times minus 2 is plus 6, so I'm going to have x squared minus 5x plus 6. And yes, we've got the same equation, so this has been factorized correctly, and we've got our x-intercepts. Okay guys, so the final example we're going to look at is example number 4. And we can see that we've got the equation x squared plus 6x plus 4 equals 0. And then I also have written down here complete the square. So why would we use the complete the square method? So in all cases, we can't always use the common factor rule, because like it says, two numbers that add to b but multiply to c. So in this case here, we need two numbers that add to 6 but multiply to give 4, which we can't find. Not in this situation anyway. There's no two numbers that add to 6 and multiply to give us 4. Right? This has told us to use complete the square. So your normal quadratic equation looks like y equals ax squared plus bx plus c. Right? So if we want to get x squared by itself, like we do here, we're going to divide that by a, divide that by a, divide that by a. Y equals x squared plus bx on a plus ca. What the complete the square method tells us to do is that y equals x squared plus bx on a. We're going to add in a term. Add in this, then we're going to subtract it, so it's like we're never adding it in the first place. If I add 4 then subtract 4, I'm resulting with the same answer that I began with. So let's attempt this. So this is saying now that y equals x squared plus, here we've got 6x, and then a we've got 1 plus, so saying b, which is 6, 2, 1 squared minus, the same thing again, c is 4, on a is 1, so y equals x squared plus 6x, so 6 divided by 2 is 3, 3 squared is 9, we're going to minus 9 and add 4. So really this and this are almost identical. The only two different things we have here is we've got this plus 9 and then we're subtracting the 9. Right? But here, this point here, we can now use the common factor rule on this portion. So now I need two numbers that add up to 6 but multiply to 9. So what are those two numbers? 3 and 3. 3 plus 3 equals 6. 3 by 3 is 9. So I can factorize that to x plus 3, x plus 3, right, minus 9 plus 4. So then this can be even made simpler because it can be written as x plus 3 squared, right, and then minus 9 plus 4 can be written as minus 5. So y equals x plus 3 squared minus 5. So now if I was to find the x-intercepts for this equation, so y equals x plus 3 squared minus 5. Right, so we're going to make y equals 0. So x plus 3 squared minus 5 equals 0. So now what I want to do is I just want to manipulate this minus 5. So I'm going to make it look squared. So x plus 3 squared minus square root 5 squared equals 0. If I square root something, then square root, I'm starting with the number I started with. Square root of 4 is 2. 2 squared brings you back to 4. Right? So pretty much squaring something and then square rooting it is pretty much doing nothing to it. We're just sort of manipulating it. So I've got squares and I can bring this x plus 3, I can bring the square root of 5 within these brackets. Right? So then I'm going to have x plus 3 minus the square root of 5 equals 0, and then x plus 3 plus the square root of 5 equals 0. So my x-intercepts are going to be minus 3 plus the square root of 5. It's going to be one of my intercepts, and my other intercept is going to be that. So out of all this, this is probably the least most important portion of what we just did. The most important portion was understanding the complete the square rule. So adding in terms in green. So pretty much we've added it, then subtracted the exact same term, which really is we're not doing anything, are we? If we add 4 and subtract 4, well then we're back to 0. Right, so we're just adding in two terms to manipulate our equation so we can get it to a point where we can use the common factor rule and then make it more concise. Alright guys, so I hope that was understandable, and thank you for watching. Bye.